So in this class, let us do some more problems on conservative vector fields. Let us move on to the problems. So consider this problem. In this problem, the vector field f is given to be yi plus xj plus zk. We have to show that this particular vector field is conservative, and after that we have to find the corresponding potential function. So let us start with the vector field. Here the vector field f is given to be yi plus xj plus zk. So this is a three-dimensional vector field. So here we have f of xy is equal to y, g of xy is equal to x, and h of xy is equal to z. We have already considered a remark, a note in which it says that if f is a vector field in three-dimensional space, then if it satisfies the conditions dou f by dou y equal to dou g by dou x, dou f by dou z equal to dou h by dou x, and dou g by dou z equal to dou h by dou y in a open simply connected domain, then f will be conservative. Or equivalent to that, if curl f equal to 0, then also f will be conservative. So let us check it with the second condition. You calculate the curl f. So curl f is equal to del cross f by definition. This is equal to determinant of I, j, k, dou by dou x, dou by dou y, dou by dou z, y, x, and z. So let us calculate this particular determinant. So del cross f is equal to del cross f is equal to I into dou by dou y of z minus dou by dou z of x minus j into dou by dou x of z minus dou by dou z of y plus k into dou by dou x of x minus dou by dou y of dou by dou x of x minus dou by dou y of y. So this is equal to dou by dou y of z is equal to 0, dou by dou z of x equal to 0, dou by dou x of z equal to 0, and dou by dou z of y equal to 0. So the first two terms are equal to 0, plus k into dou by dou x of x is 1, and similarly dou by dou y of y is equal to 1. So this is equal to 0. So we obtain that del cross f equal to 0, that is curl of this particular vector field is equal to 0. This means that f is a conservative vector field. F is conservative. Now the next thing that we are asked to do is to find the corresponding potential function. So we know that since f is a conservative vector field, there exists a scalar function f is given by f is equal to yi plus xj plus zk. F is equal to yi plus xj plus zk. So since f is conservative, there exists some scalar function phi such that the gradient of phi is equal to the vector field f. Gradient of phi means this is equal to dou phi by dou xi plus dou phi by dou xj plus dou phi by dou zk. So equating the corresponding terms of the vector field f and the gradient of phi, we obtain dou phi by dou x is equal to y, dou phi by dou y is equal to x, and dou phi by dou z is equal to z. So now we have the first order partial derivatives of the scalar valued function phi, and now what we have to do is that we have to find the particular scalar function phi. Phi will be a function of three variables x, y and z. So we have to find phi of x, y, z. So in order to find phi of x, y, z, either we have to integrate dou phi by dou x with respect to x, or dou phi by dou y with respect to y, or dou phi by dou z with respect to z. So let us do this problem by integrating. So you integrating dou phi by dou x, dou phi by dou x with respect to x. So you integrate this. So actually integral dou phi by dou x with respect to x, this is in fact phi of xyz, phi of xyz equal to dou phi, integral dou phi by dou x with respect to x. This is in fact dou phi by dou x is y, so this is integral y dx. Since with respect to x, y is a constant, y can be treated as a constant. This is y into integral dx, and this is equal to yx plus some constant. So in this case, what will be the constant? That is the next matter. So you are actually integrating dou phi by dou x with respect to x, so that y and z, the variables y and z can be treated as constants. So the constant of integration will be generally a function of y and z. So we will have as an extra term, there will be an additional term of y and z, a function of y and z. So this will be yx plus a function of y and z. So here we obtain phi of xyz to be xy plus some function of y and z. So let this be equation number 1. Now all we have to do is to compare the partial derivative of phi with respect to y or phi with respect to z with the already existing partial derivatives dou phi by dou y and dou phi by dou z. So from equation 1, so from equation 1, you differentiate, you partially differentiate equation 1 with respect to y. So from 1 you obtain dou phi by dou y as, this is equal to derivative of the partial derivative of xy with respect to y is x plus k is a function of y and z. So the partial derivative, what will be the partial derivative of this particular term? This k of yz with respect to y, it will be some dou k by dou y. So you obtain that dou phi by dou y is equal to x plus dou k by dou y, but we already know that from here we know that dou phi by dou y equal to x. So we equate these two terms. So we obtain x plus dou k by dou y is equal to x plus dou k by dou y is equal to x. So from this you obtain dou k by dou y is equal to 0. That is the derivative of the function k with respect to y is equal to 0. So this means that the k of yz does not contain a term of y. That is, k of yz is in fact a function of z only. That is the meaning of you actually obtain dou k by dou y equal to 0, which means that you obtain k is a function of z only. That is what you obtain. So from this observation you can write phi of xyz as, this is equal to xy plus k of yz will be a function of z only. So let me write it as some g of z. Okay, it does not contain a term of y. That is why we obtain dou k by dou y equal to 0. So let it be equation 2. Again we have another unknown function g of z. So we have to find what is that function to be. So you again differentiate this particular function phi of xyz with respect to partially with respect to z. So differentiating partially differentiating equation 2 with respect to z, you obtain dou phi by dou z. Dou phi by dou z is equal to derivative of the partial derivative of xy with respect to z, it will be 0 plus the derivative of g is a function of z only, so its derivative will be the total derivative g dash of z. But we already know that dou phi by dou z equal to z. So equating these two terms, we get g dash of z is equal to z. G dash of z equal to z means that g of z will be z square by 2 on integrating both sides with respect to z, z square by 2 plus some constant k. So in effect, what we now obtain that equation number 2 now becomes phi of xyz is equal to, it was actually xy plus g of z, this was equation number 2, this becomes xy plus, we obtain g of z as z square by 2 plus k. So our scalar function will be phi of xyz is equal to xy plus z square by 2 plus k. So that is our scalar function, and that are the things asked to show in this particular problem. I hope that it is clear to you. Now let us move on to the next problem. So in this particular problem, show that it is asked to show that the vector field f of xy given by e raised to x cos yi minus e raised to x sin yj is conservative, and hence evaluate the integral line integral over c f dot dr for any path c joining the points 0, 0 and 2 pi by 4. So just like the previous problem, we have to first of all show that this particular vector field is a conservative vector field. Since this is a two-dimensional vector field, we need only to prove that dou f by dou y will be equal to dou g by dou x by the conservative field test. So we have f of xy is e raised to x cos y, g of xy is equal to minus e raised to x sin y. So what will be dou f by dou y? Dou f by dou y is equal to dou by dou y of e raised to x cos y. This is equal to, since x is a constant, e raised to x into dou by dou y of cos y. It will be equal to minus sin y. So dou f by dou y is equal to minus e raised to x sin y. Now let us calculate dou g by dou x. Dou g by dou x is in fact dou by dou x of g. G is minus e raised to x sin y. Minus e raised to x sin y. This is equal to, you can take minus sin y outside, minus sin y into dou by dou x of minus e raised to x. It will be again dou by dou x of e raised to x, sorry, not minus e raised to x, so dou by dou x of e raised to x. So it is again minus e raised to x sin y. So here what we obtain is that dou f by dou y is equal to minus e raised to x sin y, and dou g by dou x equal to minus e raised to x sin y. So we obtain that dou f by dou y is equal to dou g by dou x, and this means that the vector field, this particular vector field f is conservative. F is conservative. So we are done with the first part. Now we are asked to evaluate the integral, line integral over c f dot dr. So in fact, line integral over c f dot dr is the work done to move a particle from the point 0, 0 to 2 pi by 4 along a path c. But since f is a conservative vector field, we know that this particular work done depends only on the endpoints, that is only on 0, 0 and 2 pi by 4. So we already know that line integral over C f dot dr is in fact, and before that, since f is a conservative vector field, there exists a scalar function phi such that f is equal to gradient of phi. So by a previous result, we know that this particular work done is just the difference of the values of the function phi at the endpoints. So this is actually phi of 2 pi by 4 minus phi of 0, 0. So all we have to do is to calculate this particular scalar function phi. Then we will be able to calculate the work done. So let us try to calculate this particular scalar function phi. So we have f is equal to e raised to x cos y I minus e raised to x sin y j, and this is equal to the gradient of the scalar valued function phi. So this is equal to dou phi by dou x I plus dou phi by dou y j. So equating the corresponding components, you obtain dou phi by dou x is equal to e raised to x cos y, and dou phi by dou y is equal to minus e raised to x sin y. So just as in the previous problem, what we have to do is to integrate either dou phi by dou x with respect to x or dou phi by dou y with respect to y. So integrating dou phi by dou x with respect to x, we actually get the output to be phi of xy. Phi of xy is a Rickert scalar function. Phi of xy is equal to integral dou phi by dou x with respect to x. This is equal to integral e raised to x cos y dx. You take cos y outside, cos y into integral e raised to x dx. This is equal to cos y into e raised to x plus, since the integration is with respect to x, there will be a constant of integration, and since we are treating y as a constant, this particular constant of integration will be a function of y. So it will be a function of y, k of y. So what we obtain is that phi of xy is equal to e raised to x cos y plus a function of y. Fine. What is the next step? What we have to do is that we have to actually partially differentiate this particular equation 1 with respect to y. So from 1, partially differentiating 1 with respect to y, we get dou phi by dou y is equal to, it's in fact the partial derivative of y of cos y e raised to x plus the partial derivative of k of y. So this is equal to e raised to x into minus sin y plus k dash of y. Fine. But we already know that dou phi by dou y is equal to minus e raised to x sin y. So equating the corresponding terms, we obtain e raised to x into minus sin y plus k dash of y is equal to minus e raised to x sin y. That is, clearly k dash of y will be equal to 0. K dash of y equal to 0 means that k of y will be a constant, say some constant k. So now what we obtain is that So equation 1 becomes phi of xy is equal to e raised to x cos y plus some constant k. So this will be our scalar function, the required scalar function phi. So now that is phi of xy is equal to e raised to x cos y plus k. So we are not done with the problem. We have to calculate the work done. So in order to calculate the work done, we have to calculate the value of the scalar function at the endpoint. So this is equal to phi of 2 comma pi by 4. Substituting the value x equal to 2 and y equal to pi by 4 in phi of xy, we get this is equal to e square cos pi by 4 plus k minus e raised to 0 cos 0 plus k. This is equal to e square cos pi by 4 is 1 by root 2 and this k gets cancelled, minus e raised to 0 cos 0. Cos 0 is 1, e raised to 0 is 1, so minus 1. So finally we obtain that this particular work done, the value of this particular work done is e square by root 2 minus 1. So work done is e square by root 2 minus 1. Hope that it is clear to you. So now let us move on to another problem. So show that line integral over C y minus 4xz dx plus x dy plus 3z square minus 2x square dz is independent of path, and hence evaluate this particular integral along any path joining the points 1, 1, 1 and 3, 1, 4. So again this problem is about conservative vector field, and just the appearance of the problem has just changed. So here from this problem we can first of all write what is the vector field F. So its x component, y component and z component are given. So our vector field F is here y minus 4xzi plus xj plus 3z square minus 2x square k. So we have to prove that this particular line integral is independent of path. In one of our previous theorems we have stated that the path independence is same as the conservative nature of a vector field. So in order to show that this integral is independent of path, we need to show only this particular vector field is a conservative vector field. This is a 3-dimensional vector field. So we have to prove that del cross f equal to 0. So let us calculate del cross f. So del cross f is equal to determinant of I, j, k, dou by dou x, dou by dou y, dou by dou z, y minus 4xz, x and 3z square minus 2x square. So we have to calculate this particular determinant. This is equal to I into dou by dou y of 3z square minus 2x square minus dou by dou z of x minus j into dou by dou x of 3z square minus 2x square minus dou by dou z of y minus 4xz plus k into dou by dou x of x minus dou by dou y of y minus 4xz. This is our curl f. So let us calculate it, elaborate it. Del cross f is equal to I into dou by dou y of 3z square minus 2x square will be 0 minus dou by dou z of x will be 0. So I into 0 minus 0 minus j into dou by dou x of 3z square minus 2x square is minus 4x minus dou by dou z of y minus 4xz is again there will be one more minus 4x plus k into dou by dou x of x is 1 minus dou by dou y of y is 1. So the first term is 0, second term is again 0 because minus 4x minus 4x equal to 0. So second term is again 0 and the third term is also 0. This means that del cross f equal to 0, which means that the given function f is a conservative function. So we are done with that particular part. Now we have to again evaluate this particular integral along any path joining the points 1, 1, 1 and 3, 1, 4. In fact, this particular given integral is same as the work done line integral over C f dot dr, because dr means dxi plus dyj plus dzk. We have f is equal to, if you take f equal to y minus 4xzi plus xj plus 3z square minus 2x square k, and dr is in fact dxi plus dyj plus dzk. Then if you take the dot product of f and dr, this is in fact y minus 4xz dx plus x dy plus 3z square minus 2x square dz. So line integral over C, the given line integral is same as the line integral over C f dot dr. That is nothing but the work done to move this particular particle from 1, 1, 1 to 3, 1, 4. So again in order to calculate this particular work done, we have to first of all evaluate the particular scalar function whose gradient is the conservative vector field. So we have f is equal to del phi, and our f is given by f is equal to that is y minus 4xz I plus xj plus 3z square minus 2x square k. This is same as dou phi by dou x I plus dou phi by dou yj plus dou phi by dou zk. So we get dou phi by dou x as y minus 4xz, dou phi by dou y is equal to x, and dou phi by dou z is equal to 3z square minus 2x square. So just like the previous problem, you just integrate dou phi by dou x with respect to x. You will get phi of xyz is equal to integral dou phi by dou x with respect to x, dou phi by dou x dx, dou phi by dou x dx. This is equal to integral y minus 4xz dx, y minus 4xz dx. This is in fact yx minus 4z integral x dx is x square by 2 plus since the integration is with respect to x, the constant of integration will be a function of both y and z. So it will be a function of y and z. So phi of xyz is equal to xy minus 2x square z plus a function of y and z. So this is our equation 1. Now you just differentiate this particular equation 1 with respect to y. So we obtain dou phi by dou y from equation 1. Dou phi by dou y is equal to x minus 2x square z differentiated with respect to y, it will be 0 plus k of yz, its partial derivative with respect to y is dou k by dou y. And equating this particular term with this dou phi by dou y, that is, it is already, we know that it is equal to x. So this is equal to x implies that dou k by dou y equal to 0. Again, just like in the same as in the previous problem, dou k by dou y equal to 0 means that this k of yz is a function of z only. That is, it's a function of z, say g of z. So our phi of xyz becomes, this is equal to xy minus 2x square z plus some function of z. Now again differentiating this particular phi with respect to z, then you obtain dou phi by dou z equal to this derivative becomes 0, derivative of xy is 0, derivative of minus 2x square z, it is minus 2x square plus derivative of g dash of z is g of z is g dash of z. And we already know that dou phi by dou z equal to 3z square minus 2x square. So what you obtain by equating these two, you get minus 2x square plus g dash of z is equal to 3z square minus 2x square. In other words, you get g dash of z equal to 3z square, or integrating g dash of z with respect to z, you obtain g of z as 3z cube by 3. That is, this is equal to z cube. So finally what we have obtained is that phi of xyz is equal to xy minus 2x square z plus g of z is z cube. So this is the expression for phi of xyz. So phi of xyz is equal to phi of xyz is equal to xy minus 2x square z plus z cube. Now look at the problem. We have to actually calculate the work done to move the particular particle from 111 to 314. So what we have to do? We have to subtract phi of 314 from phi of 314 minus phi of 111. So f of line integral over c f dot dr, or the required line integral, is given by phi of 314 minus phi of 111. Substitute the values for x, y and z in phi. So we obtain phi of 314 as 3 into 1 minus 2 into 3 square into 4 plus 4 cube minus phi of 111. It is 1 minus 2 plus 1. So this is equal to 3 minus 2 into 9, 2 into 9, 18 into 4, 72 plus 4 cube is 64 minus this is 0. So our final answer is 3 minus 72 plus 64, it is 8. So our final answer is minus 5. So the work done to move this particular particle from 111 to 314 is in fact minus 5. Hope that it is clear to you.